So the talk basically is about stuff we found when we were doing perimeter testing, so we're not going to be talking about Cobalt Strike or anything like that, just surprising things we found on the perimeter, how we leveraged several different issues to get a foothold. So I hope that's what you came for. Now, I used $1 billion company, but I Googled it. It's definitely true if you look at market cap. I think it's true about earnings as well. So kind of surprising that these people are not better set up really. So the basic outline of the talk, I'll introduce myself. I will give a bit of background to the problem, and then we'll look at 4 cases where the client thought everything was fine on the perimeter, and basically how we got in those cases. And as I say, we will not be mentioning Cobalt Strike. It's a great tool, but other people do it better than me. So I was indeed in the blue team. I was also a dev for my sins, and I've been a penetration tester since 2010 or so. I passed CSAS, which is the CREST red team exam, but I didn't really get to do any red teaming till 2018 or so. So I'm a relative newcomer to it. A bit of a rant first. So it's very hard to get onto red team in my experience. No one will give you a red team job until you've done a red team job, which is a problem. But equally, new people bring in new ideas. And it's very much a balance of that. When you're running a red team, you don't need everyone to be perfect. You need, as long as someone's stopping you from knocking things over, then I think there's room for quite a few different people on a red team. So there we go. The threat model is the attacker is trying all the attacks against your stuff. And for the red team side, you just need to try all the possible ways to get in and stop when one works. Now, if we want to subvert the system, we do need a reasonable understanding of how anything is working. So doing a few longer jobs gives you the ability to get in and understand how the system currently works before you can make it do things that it shouldn't do. So a bit more specifically, the perimeter that everyone has on their business is very permeable. So you've got email going in and out for classic phishing. You've got web traffic going out from corporate to the internet. You've got web traffic going in from the internet to the DMZ or wherever you call the place you keep your web servers. Then you've got VPNs, you've got help desk, especially password reset. You've got cloud authentication, you've got Citrix, you've got file exchange, you've got dev boxes. In some cases, you've got forgotten assets entirely. So can we, look at the perimeter, can we find ways to get in chaining some of those issues together? And it turned out we could in 4 out of 5 cases we looked at. So I'm too lazy to do physical. So that's not even a joke. Naught days are too hard. There are people who will do naught days. They're better than me. Things like dropped USB sticks in the car park, quite risky and not even very effective. So if you want to work from home, you can look at in-house web apps, you can look at misconfigured assets, you can look at forgotten assets, you can look at unforeseen interactions between components. Because obviously, having been a sysadmin, I know everything is propped up until it works, and then you forget about it and you go and fix the thing that's not working next. So no one's probably had a good cohesive look at everything and made sure, it's all okay. The other thing I want to mention is that issues you find on perimeter, they're very rarely independent of each other. So like if you're climbing a rock climbing wall, you might have a great hold, but if you can't get there, it's no use. Equally, a bad hold that you can get to is a great help. So when someone rates an issue in isolation, which obviously CVSS2 encourages you to do, it's not necessarily a wonderful picture of how risky it is for your particular organization. So just to follow through on the title, we spent about $8 a month on a VPS as needed. One time we got a domain name for $10. AWS account for Fireprox, which is an outbound proxy. to evade rate limiting was a couple of bucks a month as we were using it. And the scripting language, Google, patience, all free. Caffeine, actually, you can see my coffee spend dwarfs everything else. That's 2 weeks of coffee. So, before we get into the examples, user enumeration is where you have some function on your perimeter which will reveal to an attacker whether a user exists or not. So it can be a time delay, it can be an explicit message. So password reset's a common one where it literally says, this user doesn't exist, or the alternative is, we sent you a password reset email. You can also have timing attacks, so we'll see later with OWA, for some reason, valid users come back quicker than invalid users. And then the Office.com login, MS Online logins, literally just say, no, that user doesn't exist, which is obviously really helpful when you're trying to build up a list of users. So we just need some observable difference between, the two cases. And then password spraying. So the only distinction between that and normal just password guessing is, firstly, we need a lot of user IDs to make it work properly. And then we take one password and we try it against all the users. So, if you've got 1,000 users, it'll probably take a couple of hours to run through. And by that time, the naive, which I'm not being rude by naive, like the normal AD lockout counter will have reset itself. So you can then think of a new password. And, winter 2021 is probably a good guess to start with. So if you're trying against MS Online, you might need to use Fireprox, which you can Google, and it just rotates source IP addresses, so essentially they don't notice necessarily. And good guesses are things like month, year, season, year. Welcome 23. We got 2 people with Trump 2020, obviously coming up to the election. Oops. That's fine. I will. Thank you very much. But I'll press the button. Thank you. Right. So, first example, relatively straightforward. They had on-premise Exchange with about 10,000 users. So initially we used Fokker, which is a fantastic tool, to just Google the domain, pull down documents, find the metadata out of them. And you've got a few things that look like user IDs, things like IDO 12345667. So that's great. And then obviously we think, let's try something in that range. They're probably sequential. So we used bash script to create, a bunch of people in that sort of range. And then we used spraying toolkit and mail sniper to actually do the spraying. So that's the user enumeration from the mail sniper tools, which basically you give an OWA server a domain, a list of user guesses, and it will go and try them. So you can see the first one is a baseline. It's just made something up. That comes back at 3.7 seconds. And then a user which actually exists is a much quicker response at just under a second. So in that way, you can then work through your list of guest users, because even if they were allocated sequentially, some people will have left, they'll be closed or whatever, locked. So you can then use that to get a list of users who actually exist on the system and log in. So it's not difficult by any means. But you did need to be patient. We started using Mail Sniper to enumerate on the 16th of the month. We got nearly 1,000 valid users from that, which is the kind of numbers you want before you can really do this attack effectively. So we used that list for password spraying, and then obviously if we did more password spraying, we'd get a yes, no, or doesn't exist, and we'd augment or prune lists depending on what happened. And then on the 22nd of the month, so quite a long time, we got 2 passwords. And then OWA didn't have two-factor authentication, so we now have a mailbox. And because we've got a mailbox within the organization, the mail filtering coming in is a lot stricter than between internal mailboxes. So then you can do your, what crowds to write this one? CS, and you can write your custom implant. You can drop in a mail, reply to something and say, oh, I can't open this. Can you? And, that's much easier from that point. And we did get code execution in that way. So another example, which was a bit different. Again, we started off with Fokker, this time usernames for things like JSmith. So we just downloaded a list of common surnames, common first names, and again, a simple bash script to construct likely candidates. So obviously it's not going to get everyone, but it's going to get enough people probably. But in this case, the login involved, it was a standard MSOL login, but then it would redirect you to an on-premise ADFS server, which MSOL Spray doesn't cope with, either the normal or the Python version. So it was reduced to confirming whether the user existed or not, but it wouldn't tell us if the password was correct because it didn't cope with the handoff. So how could we fix that? Well, so you can see here that MSOL Spray.py is the Python port of MSOL Spray, and I just don't like PowerShell, so I use this one. I'm not sure there's any real difference. As you can see, we get a doesn't exist, and we get a could exist, and that's the limit of this in this scenario. So there's a thing called Selenium. I don't know if anyone's used it. It's more of a testing tool in a way, because it allows you to drive the browser through the whole process of interacting with the website. So it's typically used by people who need to do QA on web apps, but it's very handy. So in this case, because we had two choices, we could have read the docs on MSOL and implemented the handoff, or we could just literally use Selenium and walk the browser through the whole login process. So obviously the far end has no way of telling whether it's a real person or not at that point. That's a random snippet of code where you can look up an element by ID, then you write your password guess into it, wait for a bit, check for an error message, and then if you don't get an error message, that password might have worked. So this is a very brief demo with one failure, like one non-existent and one wrong password. So hopefully that will play. So you can see it's Selenium Python's booted office.com, clicks on sign in, types in the email address very quickly, which you'll see, and yeah, there you go, bang. That user doesn't exist, and we've looked at that on our page, so we can see unknown user, imaginary Jeff, and then save again, restart the browser, put in a user that does exist, which is me in this case. So let's try and sign you in, and then you need to, in the code, you need to handle this extra path of there being a password. So you put in our password guess, because my password is not February 2021, obviously. And so essentially, instead of interacting with the MSOL API, you can simulate that, and obviously, in that same manner, you can simulate any possible web login that exists. Sorry. There we go. So, going back to Brewer, again, we use OSINT, got some example UIDs, generalized that list, sprayed a couple of thousand usernames, as it turned out, only getting existence checks. Then using that Selenium process, we got about 10 passwords out, so a couple of thousand. And again, it was month, year, season, year, things like that. Now, the business had enabled two-factor authentication for everything, but it was register at first login. And because of what the business did, a load of people had never logged in. So in this case, we could simply register our own two-factor tokens for those accounts and start using them. So again, it seems obvious in hindsight, but obviously someone's just gone, yeah, two factors enforced, so it's fine, isn't it? So in terms of user enumeration, we tend to see either first name, last name, things like that, or an ID, and obviously those are relatively easy to generalize to more people. Occasionally people will have like a couple of initials and then a 3-digit number, and that makes the search space quite big. And potentially intractable. So that might cause problems. So this is the only bit where phishing appears, because essentially on our perimeter checking, we'd already guessed 2 creds, but they didn't really have enough privileges for our purposes. Like I think no useful remote access. But there was an open URL redirecting a holiday booking app, and obviously people care about being paid and they care about holiday. So what we did was we hosted a cloned page. So I mean, obviously everyone knows how to do a phishing page, but we were upfront with our clone page had, no, that was wrong, please try again, because we knew it was going to get bounced off. And so essentially the phishing email had a legitimate link in it, and the SSL cert would have looked fine and everything like that. So really quite difficult. And then we sent out a mail to a bunch of people that said just sort of things like, we had a system crash, some of the holiday bookings recently have been lost, please could you check? And of course everyone wants to check that. So the users would get external in the subject line, but the link, it was very obviously to their own site. So the real site, when you entered your username and password, it would create a valid session, but because of the open URL redirect bug, it would then redirect to our phishing page, which had like, no, that didn't work, please try again. At which point we would log the creds they retyped, and then we'd redirect, and then they got back into a valid session. So no one even really noticed they'd been phished. So I'll just go through because I don't want to use the actual client. I'll use the ASUS router, which was fixed and it's long ago. So, but it's very much the same bug. There's an open URL redirect on the page parameter there. So you could phish someone by going, please update the firmware on your ASUS router to visit this page, which I say is fine. And an ASUS router will resolve that domain name to itself, essentially on the way out if you're behind it. So the initial page would look like that, like absolutely normal. You'd enter your creds. If they're correct, which they probably will be, it will redirect you to the phishing page, which already says, no, that didn't work, because we want people to type it in again. So this is our fake phishing page at router-asus.com. We log the creds that people type in, then we dump them back into their existing session. And, they don't, unless you notice like your password autocomplete doesn't work, there's no real way of knowing that. So although IT had used the domain squatting service and blocked our URL on the corp proxy, it was the middle of COVID and it was kind of chaos. Everyone was working from home, and there was a major holiday coming up. So that got us about 12 sets of creds, including some with remote access, which is what we'd asked for. And IT didn't get made aware that there was a phishing attempt because the people who got phished didn't notice, and they blocked everyone who's actually on site. So last example, again, it was a hybrid AD in MSOL in the cloud. We had numeric ID, so we could guess a good range. And this time everything was two-factor, except for ActiveSync, which is what I considered a legacy protocol until I found it in use. But you can use Windows 10 Mail to send email effectively. If you can give the right creds, we didn't need to give two-factor, and then you can synchronize your mailbox, which means you can send and receive mail. So the tool we used to tell us this was called MFA Suite, which is really good. So if you have valid creds for MSOL, like the Office.com authentication, MFA Suite will try, I think, about 7 different services to see whether two-factor is in use across everything. If it finds anything it's not, it will suggest tools. So in this case, it said use Windows 10 Mail. It's like, oh, brilliant. And if you're wrong, it'll lock the account out because it tried 7 different things. So you do need to be a little bit careful. And equally, if you're trying any web logins, you need to be aware that a common way of doing MFA is to text people. And obviously that might alert someone, especially if you text them in the middle of the night their time. So somewhere in the config, you can go and set up an Exchange ActiveSync account, and then literally just synchronize mail. And as I said before, filtering mail coming from outside, typically people will remove X's, they'll remove anything that's got macros in it, even zip files on occasion. Whereas if you're sending from one internal user to another, you've got the context of what the conversations they've been having is, which is great, and you'll be able to send a bunch more file types. So you just say something like, "Oh, I can't open this. Can you open this?" and then see what happens. So this is the kind of aphorism you hear quite a lot, but generating your path through the graph is quite a hard thing. You need to try many things. Breadth first search. Essentially, try some things, follow the promising leads, but also a load will be dead ends, and you won't get anywhere, and you need to come back and think again. So yeah, we were surprised that it was so not easy, but it should have been harder to get that foothold inside those 4 companies, essentially. So I guess in conclusion, and I've kind of color-coded this slightly, minor issues are not always minor, especially in combination. And a lot of the things on the perimeter will give you enumeration of one sort or another. If you want password spraying to work, you need to really have a lot of users for it. So where we've been scoped down to say, oh, you can try these sort of 200 people, probably not going to get it. But if they're a bit more generous with the scope and just say, do what you can, then it's certainly an option. And indeed, bigger companies can be easy to get into in this manner because obviously, we had 10,000 users to have a go at, whereas if you've got 100 users and they all sit in the same room as the IT guy, that's a very different problem. From the blue team side, it's essentially the combination of us being able to identify users and just have a go at guessing passwords without anyone intervening. So obviously you need to be aware if people are trying this attack. And just because you've outsourced some of your authentication to Microsoft doesn't mean that Microsoft are going to be looking at this for you unless you pay them to do so. So you can mitigate it at various points, obviously. You can get rid of weak passwords like Summer 2020, but also you should be aware of if people are trying this. And I'd recommend testing your own stuff to make sure. Essentially, to answer some of these questions, you don't need to engage a pen test company. You can just try it and see what happens. Like, do you notice accounts being locked out en masse? And so that is it, essentially. Are there any questions? Nick?
When you said that you used the legacy protocol, did you speak to the clients afterwards and find that that was there for about a reason?
I don't know. I think of it as legacy protocol. It seems it's actually current. But it used to be that if you had an old device, like with some of the older phones, they would talk ActiveSync, and therefore that would be a reason why you wouldn't necessarily have two-factor on it. But I'm not aware of anything. None of my stuff speaks ActiveSync, so. Sorry. Oh, yeah.
So in our workflows, we often use Selenium to pull together patching integrations. Have you ever noticed it's used in more malicious cases, more malicious actors using things like Selenium and Python-based workflows?
So I haven't personally, but it's a very flexible tool, but obviously you need to put in dev work, and therefore, if there's an off-the-shelf tool that does the job, then I will use that because it saves everyone time. Whereas we had to develop this because I couldn't find anything that would do the job. But apart from that, I don't have a great deal of experience of Selenium because I don't test web applications. But it's a very useful tool and it can be very handy when you need it, I guess. Yeah. I think. So I think in some cases, because they had a password, Windows has a password policy, and if everyone's got a strong password, and especially if you tick the everyone must use two-factor box, maybe you would think that everything was okay. But I'm kind of suspicious, and I always like to look at least authentication failures, and if you've got a lot on whatever system, because especially with acquisitions, people tend to accumulate more companies and kind of merge them in, but not entirely. So it's not like you have one central source of authentication either. Some various other things may give you a yes, no, or a password. So actually tracking everything through your whole organization is quite a hard problem. But I'd suggest at least your normal ID and whatever you've got in the cloud should be monitored quite carefully, even just so you can sleep better at night.
Comment on how what timeouts and what proxies you use for Azure AD. It is quite you can't really be attacking from one box.
Yeah, we used Fireprox.
So what is Fireprox?
So there's an Amazon service which I think is for outbound APIs, but essentially what it gives you is a outgoing proxy rotating around different IP addresses, and that I think we didn't have to use it in one of those cases, but in another we did, and that seemed to get us around the rate limiting on Azure AD. Okay. Sorry, there's one at the back. I'm sorry. Sorry, Tim. Could you take your mask off? So there's a lot of decent log analysis stuff these days. I'm used to collecting everything in a big syslog and graphing it myself, because we didn't have that tooling when I was doing it. So I'm sure there are, and I'm sure Splunk would do it, but equally Splunk is expensive. There may be intermediate options, but I'm sure there's many things you could put the data in and then query it for authentication failures. And equally, the same user should not be rotating around IP addresses and things like that, but that might have to be a custom query. And obviously your inbound reverse proxy might be destroying that source information and all these things. So definitely worth seeing if you can capture that kind of stuff, but it's not the same at every organization. So. Okay. Right. Well, I guess we'll wrap up there. I have no idea if we ran to time or not. Thank you.